All right. So here's a problem that we're stumbling on in class. And by we, I mean I. So I have f of x equals 3x to the fourth plus x. And I see that g is the inverse function of f. I want to find g prime of 2. First of all, let's get rid of this stupid g. I don't know why they include it. It's really creating confusion. So let's just use f, because I know that g is the inverse. So I want to actually find f inverse, the derivative of that at 2. That way we're all using the same letter. We're not introducing this weird g. So I want to find the derivative of the inverse of f at 2. Now, this is what was confusing a lot of us. Let's say this. This is basically if I went up to the function, the inverse 2 equals, let's say, just blah, something. Now, if we went backwards to the function, remember we switch our x with our y with our x. So for the function, this is saying that f of blah is equal to 2. So this up here is code telling us that y is equal to 2. So this is telling us that our y value is 2. So to start off, step 1, find the x value. All right, I need to find the x value. So I'm going to set this equation equal to 2 to find my x value where this makes the function 2. So I have 2 is equal to 3x fourth plus x. Now what we were trying to do, what I was trying to do in class, is factor out an x and set those equal to 0. This is what I was trying to do. I was trying to say, well, 2 is equal to, let's factor out an x, 3x to the third plus x, plus 1, and set those equal to 0. Set those equal to 2. But this only works if they're equal to 0, right? Because if I set x is equal to 2, that means that this has to be 1 for this to be true. And that's not the case. If this is 0, anything times 0 is 0. That's why when we're finding like roots and things, that's why we set it equal to 0. So this is a big old no. That's where we were going wrong earlier. Okay? To solve this, really the easiest way is I use my calculator. So I'm going to go to my y1. I'm going to plug in 3x to the fourth plus x. My y2, I'm going to plug 2. So I'm going to go see where they're the same. All right, I'm not seeing anything there. I go up. All right, I have one of them. I know that at least one place x is equal to 1. So I'm going to plug that in here. X is equal to 1. But I also have a second one, right? Somewhere in between 0 and 4, I know it has to equal 2. So there's a hidden 0 right in there. So I'm going to go to my graph. Instead of using the table, I can use the second trace button to find the intersection over here. Second trace, go down to intersect, give my cursor close to it, click enter, 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 and it gives me my other x value when y is equal to 2. So my other x value is x equal to 0.796. Because of the cubic nature of this, I might have two different answers. This is why I get two different answers. So I'm going to set up my equation. Step 2. Set up your equation. My phone is going off. Everyone panic. Okay, so I know that if So I want to find the derivative of the inverse at 2. This is equal to 1 over f prime of f inverse at 2. Okay, well this up here told me an important piece of information. Using this inverse up here, because that's my y value, from my x. So this is f negative 1, the inverse at 2 is equal to 1, or f inverse at 2 is equal to 0.796. Two different answers. So I'm going to have version A, I'm going to call this A, and version B. So if I use version A equals 1 over f prime, substituting this value in, of 1. Version B equals 1 over f prime of that nasty decimal. Now to get this part, I have to use step 3 and take the derivative. Oh, derivative. Yep. That's not right, but oh well. This is math, not spelling. So I take the derivative of f of x. Remember, f of x was equal to 3x to the 4th plus x. So f prime is equal to 12x to the 3rd plus 1. I have to substitute two things in, right? My f of 1, f prime of 0.796. So f prime of 1 is equal to 3, this is 1 to the 4th plus 1. And f prime of 0.796 is equal to 12 times 0.796 to the, sorry, this is to the 3rd up here. It should be 12 3rd plus 1. This is plus 1. So these come from these derivative equations. And then I can take these values and plug them in here and in here. And that gets me my f prime of the inverse of 2. And that's just plugging stuff into your calculator and solving. Remember, it's 1 over those values, not just those values. Okay, that is problem number 5.